Good morning, and thank you for the introduction from Tracy and Maria there, and welcome to our session this morning on HACCP, an introduction to HACCP and record keeping. Just to introduce myself a little bit more, I have over 30 years experience working within the food industry, and for the past 22 years of that, I've worked in the role of consultancy. Through this time, I've witnessed both good examples of effective application of HACCP principles. However, I've also encountered many examples of when HACCP hasn't quite worked, and I hope to be able to guide you through these pitfalls today. I've worked with both large and small scale food processors, as well as storage and distribution sites, and catering both in small and larger scale, such as hospital catering. I'm also fortunate to work in other associated industries such as food packaging, and have been able to apply the principles of HACCP there also. HACCP is a system which can cause apprehension among those starting to apply the principles. However, please do not let the jargon put you off. I hope to take away some of the mistake out of the system today and guide you through this process to enable you to successfully apply the system in a manner which will benefit your organisation and ensure that you have a robust food safety management control system. It is a well-known, practiced food safety management system. HACCP is an acronym and it stands for Hazard Analysis Critical Control Point. It's important early in today's presentation to make it clear that the objective of a HACCP system is to manage food safety. It is not designed to manage quality, and you will have many more quality issues and concerns within your business than you will have with regard to food safety. These, of course, are extremely important to your business, but the purpose of the HACCP system is to manage food safety. So we don't want to muddy the waters by adding in quality along with it. I want to introduce a concept to you of food safety culture. It's nothing new, it's been there for a long time. However, it's found a new voice in recent years. Food safety culture embodies the beliefs and values within your company, and HACCP and food safety management control is central to this. HACCP is a system which will help us ensure that we follow good food safety culture. Behaviours to food safety control will be driven by the values and standards that you as a senior management team set. You need to lead from the top and you need to plan and manage this change. You need to instill the behaviours, train and communicate these behaviours out to your staff, and provide the resources for them to do that. You have the responsibility to ensure that this culture is being achieved by monitoring, verifying, and reviewing. There are many benefits of having a good HACCP system implemented within your organisation. It's a preventative, systematic approach. It's a proactive approach. You should be able to identify all currently conceivable hazards, including those that have not occurred but can realistically be predicted to occur in the future. And let's prevent making unsafe food rather than reacting to it when it actually happens. So the purpose of your HACCP is to think about what potentially could go wrong in your process and make sure that it doesn't go wrong. This will then increase your confidence in product safety. It has the potential to identify these areas of concern where failure has not yet been experienced, particularly useful for new operations and thus giving you control in that. It's an effective use of your resources. We don't have a never-ending supply of resources. So control can be transferred from, for example, end product testing, which is testing for failure, into the design and manufacturing process, i.e. preventing the failure. It's a cost-effective control of foodborne hazards, and it focuses your technical resources into critical parts of the process. For example, you can look at the maintenance of your business and the maintenance activities and concentrate the maintenance on the key parts of your process which are critical from a food safety perspective. Again, with regard to training, you can look at the training for all personnel within your organisation and then concentrate and make it very bespoke, any training that are required for people working at critical parts of your process. It is a legal requirement to have a HACCP-based system, and under European law, we need to ensure that we comply with that. Under 852/2004, the Hygiene of Foodstuffs, Article 5, it states that food business operators shall put in place, implement, and maintain permanent procedures based on HACCP principles. And these principles that are mentioned in our legislation very much mirror the Codex 7 principles that we're going to look at today. We can therefore use HACCP as part of our due diligence defence. So it shows that we've got a system of control, but more importantly, we have fully implemented that system of control and it has been maintained if we're going to use it as a due diligence defence. It can also help inspections from a regulation point of view and other external audits, as this can become central to the focus of our audit. It demonstrates management commitment by effective food safety management. It covers all aspects of the production, from raw material, growing, harvesting, processing, to the final product. So there are many, many benefits of having a HACCP system. I'm a great believer in HACCP. However, I have experienced occasions when HACCP has not worked. And why might these be? Lack of knowledge of those putting the HACCP plan in place, improper application of the principles, incomplete, inadequate implementation, so writing a plan but not actually implementing it correctly, not keeping your plan up to date, where perhaps you introduce new products or new processes and that you haven't then updated your plan, or new information on existing hazards come to light which have not been considered, or indeed new hazards when they come to light. So it's important that the plan is constantly reviewed and make sure that it is maintained. Or simply incorrectly identifying potential hazards. So perhaps ignoring hazards or not being on top of hazards and not controlling them. So lack of understanding can be a real problem. So not using a team approach, relying on a student on placement to actually put the plan into place, missing significant hazards, relying on buying in a generic system which does not fit your organisation, and therefore you miss significant hazards in your process. Not using, for example, the CCP decision tree correctly and not then identifying the appropriate CCPs. Not identifying all hazards, controls not being adequate, critical limits for CCPs not being the point between safe and unsafe food, or inadequate or wrong or poor monitoring procedures. So there can be lots and lots of problems that can be introduced if the HACCP plan is not carried out, the study is not carried out correctly. And this can give your business a false sense of security, thinking that on paper you have a good system, when in actual fact, the system is not there. So being aware of potential pitfalls can make it easier to try and achieve a safe system. I want to introduce a little diagram that I have developed to try and help explain the hazard analysis process. So I see the hazard analysis process as a filtration process. And at the top, we throw in all potential hazards that we can think of in our process. And you would do this at every step in your process flow diagram. You would throw in all the potential hazards that you can think of. And you then put it through a series of filters, which in my case, in my diagram, are the red, that is the red writing. So in at the top at stage 1 or step 1, we have hazards, okay? And we've identified potential hazards that could occur. Our first question, are these food safety hazards? If they are food safety hazards, we bring them through to layer 2. If they're not, we leave them behind, because remember that we are only looking at food safety hazards. So if they're of quality nature, we don't need to worry about them within our hazard analysis process. So we now go to layer 2 and we now have food safety hazards only. So we've reduced the pool of hazards down. We then need to identify whether these food safety hazards are of significant nature. In other words, they're likely to happen, likely to occur, and if they did happen, they could cause some level of harm to the consumer, and therefore they're known as being significant. If they're not significant and they're low risk, then again, we can leave them behind. And a lot of time, these non-significant food safety hazards are then controlled by prerequisite programs. If they are, significant, we bring them to layer 3. And layer 3 onwards is where I believe we need to put our focus. So we now have significant food safety hazards, and Codex Alimentarius tells us that all significant food safety hazards must be controlled. So we then start to look at the controls and the current controls that we have in place and see if these are adequate or not. So we ask the next question, are they already being adequately controlled by prerequisite programs? And don't worry, I'm going to go through what prerequisite programs are with you. So if they are being controlled by prerequisite programs, we need to check that those prerequisite programs are robust enough, okay? So we do a gap analysis of our prerequisite programs and we check that they are indeed controlling that specific food safety hazard that we've identified at this step. And if we're happy, then we cross-reference out to those prerequisite programs and we don't need to go any further. If they're not, we bring them to layer 4. So we now have significant food safety hazards which are not being controlled by prerequisites, or you might use a term operational prerequisites, but I'm not going to go into operational prerequisites today with you. It's just an additional layer. So if we are happy that they are controlled, we leave them behind. If not, we bring them to this layer 4. So if they're not being controlled by prerequisite programs, then we can ask a question, are they critical control points? And we use the HACCP decision tree to help us. And if the answer becomes yes there, they come through to that final triangle and they become a CCP. So if you imagine the number of potential hazards that we threw into the diagram at the top compared to what we end up with at the end, we have filtered down to a relatively small number of CCPs. If, however, we say no at layer 4, they're not a critical control point, we still have significant food safety hazards that must be controlled. So you then need to go back and try and identify an appropriate control. So I hope that diagram helps to set the scene for what we're doing here today. It's important that we get management commitment in order to put our HACCP plan in place. And this really brings us back to the values of our business and the food safety culture. So if you're committed to ensuring that you produce safe food and putting your effort into designing up a decent HACCP plan, then that is going to help us demonstrate that we have good management commitment. You're setting the values and you're setting the standards. So what are the food safety objectives for your business? What are the consequences of losing control? How does HACCP relate to other systems that you may already have in place? For example, your quality management system. So your HACCP will relate in many ways there because it will be looking at control measures that you will have embedded into your quality management system, such as prerequisite controls. You need to consider what's involved in setting up the HACCP system. Who should be involved? What resources are needed? Do you have the necessary expertise in-house within your business, or do you need to buy that expertise in? How long is it going to take? What stage are you at? So you need to do a bit of a gap analysis to see where you're at and where you need to get to. So what we're pulling together is a HACCP plan, and a HACCP plan has a whole ream of documentation. You will have a little bit about your company, so description of your company, a little bit of background to the company, detailing what you do, where you're based, a little bit about your facility. You will refer to the appropriate legislation and any codes of practice and guidelines that you follow. So you may be following some customer requirements, you may be following some third-party standards such as SALSA, BRC, and what pieces of legislation you're working to. So you'll be looking at your European legislation. If you're based in Northern Ireland, obviously we are no longer part of Europe. However, we still follow European legislation at this stage. That may change in the future, but you still are expected to follow the European legislation. So EU 852/2004, the Hygiene of Foodstuffs, is the main body that you will be following with regard to food safety legislation. If you're handling food of animal origin at certain stages in the process, there will be additional requirements under 853/2004. Of course, we have other pieces of legislation around traceability and around control of allergens, etc. as well, which will link in very nicely into your HACCP study. We need to define the scope of our study, and we're going to look at that in a few minutes with you. So what do we include within our study? So what processes, what products are we going to include? We need a descriptor of our product and our raw materials and our processes. So how do we actually produce our products? We will have an actual descriptor of that. We will have the intended use defined. We need to know what happens to your product after it leaves your premises. How will it be used? Who will use it? The plan will include process flow diagrams, which is a mapping out of your process, which will aid you in carrying out your hazard analysis, and you will keep a copy of your detailed hazard analysis and risk assessment. There will be minutes of meetings, which will include some justifications and your decision making. And even deciding on your critical control points, you will use the Codex decision tree, and that will help you identify where you've got to and why you've got to, and we will keep those answers logged. For CCPs, we will have control charts, and then we'll have procedures. So we need to have procedures in place for all our prerequisites and for all our CCPs. In addition, we will have monitoring records, again, for both CCPs and for prerequisites. And those blank forms will be included within your HACCP plan as a reference document. And then, of course, you will have those records as evidence. So I want to introduce the Codex standard to you. Codex Alimentarius is a collection of standards, guidelines, and codes of practice which have been adopted by the Codex Alimentarius Commission. The HACCP document under the basic food hygiene text was last updated in November 2020. It has been a long-awaited change, and we've had some good feedback on some of the changes there. So a few things that will be added still to that standard. You can download it. If you go on to Codex Alimentarius website, you will be able to download it. The one I'm showing here is the 4th edition. So we don't have a nice colourful edition issued yet because it was just November last year. But who are Codex? It's Codex, it's central part of the FAO, which is the Food and Agricultural Organization of the UN, along with the WHO, which is the World Health Organization, and it's central to their standards program. They first met in 1963 and they have 188 members, and their aims are to protect consumer health, remove barriers to trade, and this facilitates international trade in a safe manner. Okay, so they agree that there can be differences between different countries, and they look at things called equivalence as well. So these principles were accepted a good number of years ago, and we had some updates in 1997, and 2003 was the main sort of update. Edition 4 was published in 2009, just with some minor admin changes, and then this update in 2020. So the changes had been delayed for some time. A lot of talk around addition of allergens into the definition, which still hasn't happened. However, a lot more detail around control of allergens has been added to the updated version, and a lot more emphasis on the role of the food business operator as well. And one very welcome change that until now, the word prerequisite was not used within the standard, but they now use that terminology and now have a definition for that, which is really good to see. So there are 7 principles that we follow when we are carrying out a HACCP study, 7 principles that come from Codex. One is to conduct your hazard analysis, and within that, we include identifying potential hazards, risk assessing those hazards, and then coming up with adequate control measures. We then determine where the critical control points in our process are, and for those we lay down parameters for those to work within, which are known as critical limits. We then need to check that we're working within those critical limits, which is known as monitoring procedures. Vast majority of the time when we're monitoring our critical limits, we will see that we are in control. But on occasions, we will find that our critical limits are not being controlled. And in those situations, we need to put in place the appropriate corrective actions. And then the last two principles are around verification activities and the need for documentation and record keeping. So if you were handed those 7 principles and asked to do a HACCP study, you may struggle a little bit. So they've broken it down further into something called the logical sequence. And there are 12 steps in the logical sequence. There are what we call the preliminary steps, which are 1 to 5, and then they follow on to the 7 principles. So the preliminary steps are assembling your HACCP team, describing your product, identifying the intended use of your product, constructing your process flow, and then on-site confirmation of your flow. And then we add in our 7 principles. I'm going to add 2 more additional steps. So these are not strictly Codex. However, it's very well documented that we should include defining your scope and terms of reference. So I've added that at the top. And finally, at the end, review. And in fact, legislation does mention the need for review. So that has clearly been added into European legislation. You may need to define your scope and terms of reference in order to be able to identify who should be on your team, or perhaps you need your team to be able to define your scope and terms of reference. So they happen fairly simultaneously. So it will be very dependent on yourself at what point you do that. So defining your scope, terms of reference, assembling your team, describing your product, identifying your intended use of product, constructing your process flow, confirming that that's correct. Then our 7 principles: conducting hazard analysis, determining CCPs, establishing critical limits, monitoring, corrective action, verification, record keeping and documentation, and finally review. So we're going to use that focus as we go through. So what I'm showing you today is what we would call Purest HACCP. So we're following the principles through completely. Of course, in legislation, there is an allowance for a little bit of a change, a bit of flexibility in legislation around the requirements of HACCP, and particularly in the catering industry. And I know some people here today are from the catering industry, and it is accepted that you may use a slightly different model to help you do HACCP. And one that I have brought with me today, and I know it's a slightly old version of it, is Safe Catering, just because I have this one in a nice folder. And that can be downloaded either from the Food Standards Agency website. So this is the one that's used which was designed by one of the environmental health teams in Northern Ireland by Southern Group. And that can be downloaded free of charge from the website Food Standards Agency. And it was previously known as the Northern Ireland model and is known as Safe Catering. You can also download that from FSAI. They endorse that model as well. And it is slightly different in that it takes the theory of HACCP and breaks it down into common speak. So it will say, what can go wrong? Brackets hazard. What do we need to do about it? Control and critical limit. How can I check it? Brackets monitoring. What will I do if it's not right? Brackets corrective action. So it's very good, and it's color coded into various stages such as purchasing, intake, cooking, reheating, hot holding, etc., delivery, service. And it also uses prerequisites. It has record forms already written for you, so you're free to use those. So it's very useful. But I think it's better to actually understand how the whole thing is brought together in order to do this. And certainly in manufacturing, I would expect that you use Purest HACCP. And if you were in large scale catering, such as hospital catering, where the risks are much higher, I believe that Purest HACCP is the way to go. So we're going to start with the team. So we need to have a multidisciplinary team. In other words, people from different parts of the organisation on our team. The core team is normally made up of production, quality, technical, and engineering. And then you bring what we call co-opted members on, or ad hoc members on, as and when they are needed. So that might be somebody from the purchasing side, it might be a microbiologist, it might be somebody from NPD. And as I said, you bring them in as and when you need those people. I have carried out HACCP plans on my own, and when I go back and I look at those, they're very much skewed from a technical point of view. I didn't have the input of other people, and I can see that those HACCP plans have not been written correctly. And yet I've worked really closely with teams to actually develop HACCP plans, and they work very nicely as a team. So it's very well documented that we should use a team approach. And you have that level of expertise from different parts of your organization, and it makes it so much easier. You should have different levels within the hierarchy of your business as well. So you need somebody senior there who has the authority to make decisions, but you also need people from like supervisory level and even some key operators, so they can actually bring very specific examples to the table. In the catering industry, you're probably going to have like a catering manager, a cook, and some key operators there, but you may also bring somebody in, say, from the purchasing or the facilities management side of the business, or you may be wearing several hats, obviously, as well. So it's important here to make sure the team do meet up and that people contribute. So having a good team leader who can lead this team is vital, and they have to have good leadership skills in order to do that. I've witnessed teams who on paper are a team, but they never actually meet. But I've also met teams who do meet, but nobody actually contributes. So they just allow the team leader to make all the decisions. So it's important that the team leader is experienced, knowledgeable, and is a natural leader, as well as completely understanding the HACCP process as well. So the team may need to get together, I said, to define the scope, or you may define the scope first to identify who should be on your team. So defining the scope, we're really looking at what needs to be included within your HACCP study. So where is the starting point? So where do I start to have control of my process, which is normally at the point of intake of raw materials? And where do I end my control? And again, that's normally at the dispatch of your product. If you are involved in purchasing, obviously purchasing will be a stage in your process, and we normally deal with purchasing as a prerequisite control. If you're involved in distributing your product right to the consumer, then you would include transportation within your scope. If you're relying on somebody else delivering your product, then that would be a third party transportation, and that would be included as a prerequisite control. What hazards am I going to look at? So I'm going to look at my sort of top 4 hazards, food safety hazards: microbial, physical, chemical, and allergenic. And then there's now a 5th hazard that we consider, which is malicious contamination and fraud. So am I considering all of these, or am I only considering part of them? You make it very clear in this definition of the scope that you're not looking at food quality, you're only looking at food safety. And am I going to group my products am I going to group products together? Am I going to do my HACCP study by a process, or am I going to use a modular approach? And a modular approach would be where you perhaps look at intake and storage as a module, and then you maybe go into various processing stages as separate modules, and then maybe bring things back in as a final packing module at the end. So it very much depends on your organization whether what is the best way of doing that. Okay, so different businesses can break their business down in different ways, and that's why generic approaches don't really work. So let's describe our product. What's our composition? In other words, what's my product made of? What are the raw materials? What are the ingredients? What are the origins of my ingredients? Because that may have an impact on a hazard. Even just who the supplier is, they could be handling, for example, allergens on site compared to another one not handling allergens, and there could then be a potential risk of cross-contamination. There could be microbial hazards of concern with some raw materials when they're being brought in from certain countries, and certainly from a fraud point of view, country of origin is extremely important. Are there any recipe or intrinsic control factors that we should be looking at? And here we're primarily looking at things like the pH value or the water activity, which is going to perhaps have an impact on whether microbial organisms are going to be able to survive and to grow. So these sort of naturally occurring controls that are in place within the raw materials. What are the principal process technologies that your product is going to go through? So what processes will it go through? Will it go through any form of heat treatment or any other preservation method? Are these capable of removing the hazards, or as my process technologies potentially going to introduce hazards? For example, you could be introducing broken pieces of equipment from machinery into your product. Or if your product is handled by personnel a lot, then you could be introducing hazards from people. How is my product packaged and what's its finished product state? So what is the packaging? Is it aseptic packaging? Is it vacuum packing? Is it modified atmospheric packing? Is it bag and box? Is it just loose in a cardboard box? Is it in a glass bottle? Again, that could have an impact on allowing or prohibiting bacteria from surviving or growing, or you could be introducing a hazard, for example, with a glass bottle. If we have breakages, then the fragments of glass getting into our product is a real potential hazard of concern. How should my product be stored? Is it chilled? Is it ambient? Is it frozen? And what is its target shelf life? So gathering this background information is extremely important before we do our hazard analysis. We need to identify our intended use of our product. Who is our consumer target group? So we talk about our at-risk group being the very young, the elderly, the immunocompromised, pregnant women, and we now have a fifth group that we add there, which are allergen sufferers. And this is a particular concern if you're making a claim with regard to an allergen, that it's really important then that we understand who our target group is. Often this is not identified correctly. You may have an end user in your conventional sense. For example, the company supplies pasteurized egg and have identified the end user as consumer who could be from any of the at-risk groups, so any of the vulnerable groups, because it's sold to the general population. In fact, they're supplying only to further processors who are then putting it into a product which then becomes fully cooked and then will go on to be served to consumers. So you do need to take into account those vulnerable groups, particularly if you're supplying hospital catering or care homes, or if you've designed a product specifically for children. Then a child will choke on a smaller foreign body than an adult would. How is your product intended to be used? Are there instructions? Does it have to be fully cooked prior to consumption? Does it have to be reheated? Or is it ready to eat? Okay, and those could have a big impact if there was abuse potential. In other words, if the consumer did not handle or store or prepare your product properly, or they misused it. So is there an alternative use for your product that you hadn't perhaps thought about? So they could abuse it by not storing it correctly, putting the product into the boot of their car, allowing temperature abuse to happen. A good example here of using alternatively is flour. Flour is designed to be added in bakery, to be baked in as an ingredient. So it goes through a heat process. But there is quite a trend at the minute where people will sprinkle flour over their baked goods to give it that homely baked feel. And so you can have flour that doesn't go through the baking process. So you would consider, is there a risk if somebody does that microbially from my flour, or am I happy that there is no risk because they're using my flour in an alternative way? So once you've done your background information, you're ready to start thinking about something called prerequisite controls. And prerequisite controls are your basics, okay? The basics that you would have in any food preparation area. Until very recently, Codex did not formally use the word prerequisite, although it was very much included within their basic hygiene text. And a lot of the preamble, as I would have called it, before you got to the section on HACCP was really their prerequisites. So a couple of definitions here for you. So the World Health Organization definition: practices and conditions needed prior to and during the implementation of HACCP that are essential for food safety. The Codex definition, which I said is very new: programs including GHP, good hygiene practices, good agricultural practices, and GMP, good manufacturing practices, as well as other practices and procedures such as traceability, that establish the basic environmental and operating conditions that set the foundation for the implementation of the HACCP system. So these are our basics. They deal with site-wide hazards, they deal with repetitive hazards, sometimes lower risk hazards, and they tend to be hazards associated with the environment, people, fabrication, and facilities such as machinery. They are not specific to a process step. So they include things like pest control, personal hygiene, cleaning, ID and traceability, product recall, record keeping, planned preventative maintenance. The list can be quite varied. Okay, so where do I get this list from? Well, there's a few different sources. So first of all, we can have a look at, sorry, I'm just going to go ahead a slide two, the Codex General Principles of Food Hygiene. And they have broken it down into the following 8 categories. So primary production, and they are looking at environmental hygiene, hygienic production of food sources. So this is right back to farm level. So raw milk, animals coming in for slaughter. So making sure that's clean, clean transportation to the factory is included there. Then we move into the factory or to the kitchen, and you've got establishment, design and facilities. So thinking about location, premises and rooms, equipment and facilities in the production environment. Then we have training and competency. So they've added competency into the update in 2020. So having training programs, instruction, supervision and refresher training, and making sure people are competent in what they've been trained in. Then we have establishment, maintenance, cleaning and disinfection and pest control. So maintenance and cleaning, pest control and control of waste. Then we have establishment personal hygiene. So health status, illness and injuries, personal cleanliness, personal behaviour and visitors. So interestingly, personal behaviour has been in there for some time. So we looked at food safety culture early on in the presentation, and here very much it's been in Codex for some time. Control of the operation, so incoming raw materials, packaging, water control, management and supervision, documentation, record keeping, ID and recall, ID and traceability and product recall. Then we have product information and consumer awareness, so batch IDs, product information, labeling, consumer education, such as storage instructions and cooking instructions, and then finally, transportation. So when we identify our prerequisite programs, we need to make sure that these control the hazards that are identified. And we do a bit of a gap analysis when we do our hazard analysis to make sure that they are controlling the hazards that we've identified. We need to validate these. In other words, are they actually going to control the hazards that we've identified? Do we have a procedure? So we need to have a procedure in place for every one of them, and we need to train our staff against them. And we also need to monitor them. So maybe not monitoring as frequently as we would with a critical control point, but monitoring them still to ensure that we know that they're robust and that they are being followed. And then we need to formally review them as well. There is a huge trend of removing critical control points out of HACCP plans and saying that everything is controlled by prerequisites. So if you think of my funnel diagram earlier on, I don't really mind how you control a hazard as long as a significant hazard is adequately controlled. So it is acceptable in many cases to control a significant hazard by a prerequisite program, as long as you can prove and you validate it and prove that it is adequately controlled. So coming up with your list, as I said, it's quite useful to use your Codex document, or there's another document which is freely available. It's a PAS document. So PAS 222/2011, Prerequisite Programs for Food Safety in Manufacturing of Food and Feed for Animals. That's quite a useful one. Now, they're quite old in some respects, but they are useful, or other standards such as SALSA, BRC, or even just in your legislation, the sections under 852/2004, you will see a lot of our requirements there fall in as being prerequisite programs. So once we've identified our prerequisite programs, we need to create a process flow diagram. And this is a mapping out of our process. And we include all our raw materials at the top, and we show how those raw materials come in, how they're stored, and then how they're handled to produce our finished product. We also include any utilities. So if you have water, gas, or steam being used as a raw material, then we would show that coming in as well. Any direct food contact packaging, and we show how each process step interacts with the next step and with previous steps. Okay, so we show how they interact with each other, and we put in process parameters such as time and temperatures and any storage conditions. If there is rework, don't ignore it, show it in your mapping out of your process flow diagram. And if you've got process delays, so things like work in progress, where perhaps the product is produced to a certain point and then stored, then show that in your process flow as well. So your mapping out of your process is very important. I've seen very simple flow diagrams and they result in an adequate hazard analysis. So make your flow as detailed as possible. It's going to help you when we move to your hazard analysis. So all that preliminary work was really important before we can get to principle number 1. And this is where we then do our hazard analysis. So when we do our hazard analysis, we break it down, and every step in our process flow diagram, we need to consider what are the potential food safety hazards. Remember, keeping it to food safety. What are the potential food safety hazards at this step? And you should go through every type of food safety hazard. So you'll be looking at physical, chemical, microbial, allergenic, and fraud and malicious as well. And you'll be looking at under each of those categories, the potential. You then need to risk assess your hazards to see how likely it is that these hazards would occur. And we use a risk assessment approach. And from that, we identify significant hazards. And Codex then says that all significant hazards must be adequately controlled. And these may then be controlled by existing prerequisite programs, or perhaps you might have to introduce new control measures. So we need to check that these are adequate, documented, and monitored. So what is a hazard? Codex tells us a hazard is a biological, chemical, or physical agent in food with the potential to cause an adverse health effect. In other words, it has potential to cause harm to the consumer. Always remember that it's the harm to the consumer that we're concerned with. So either by causing poisoning, such as food poisoning or chemical poisoning, harm or injury, such as physical injury causing choking or injury to the person by breaking a tooth or cutting their mouth, or by causing an allergenic reaction. So when we're carrying out our hazard analysis, we're always considering the harm to consumer, and we're thinking about the vulnerability of the consumer. So that's why it's important to understand who your target market is and what the level of risk that there could be. Okay, this is not health and safety harm from the people producing your product. That is completely different. It's very important, but that's not what HACCP's about. HACCP is about identifying the potential harm to the final consumer. So if we look at these hazards, we have microbiological, which are mainly the pathogenic bacteria, the ones that we're going to be concerned with. So in other words, the ones that cause food poisoning. So not spoilage. Spoilage is going to spoil the food in some way. Here we're worried about pathogenic bacteria, the ones that are going to cause food poisoning. And keep an eye on any emerging pathogens, okay? I think most of our pathogens have now emerged, but microbiological will include viruses as well. So a few years ago, we introduced a new virus called hepatitis E, which was found in chopped up pork, and it was discovered in things like sausages. But as long as you cook the sausages thoroughly, you will destroy that particular virus. So we include pathogenic bacteria. We also include viruses under our microbiological heading. But you need to understand specific microbiological hazards. So which pathogens are of concern to your product, okay? And that will vary depending on the raw materials that you're handling. Chemicals will include things like cleaning chemicals, dioxins. We've had a number of dioxin scares with food being imported in. We had the famous one in Ireland a few years ago where they used the wrong fuel to use in their dryer in the animal feed, and the dioxins then got into the animal feed, which were then fed to the pigs, and then the pigs then went to slaughter and ended up in the food chain, and there was a lot of product had to be held and recalled due to potential cross-contamination with dioxins. Veterinary drugs, antibiotic drug residues, that can be found in raw milk or in meat as well, if they're not controlled properly. And then we've added radiological into our chemical hazards now. And here we're worrying about where was your animal feeding from, what fishery, what waters was fish brought from, and could there be any risk of radiological hazards from that? And if you're using borehole water, for example, as well. So there's lots of information available out there. You can have a look at the areas where your raw materials come from, even the areas that you're producing your product in, and you can see what the radiation level may be. Physical, then, as I said before, cause choking hazards or cut your mouth or maybe cause dental damage. And then we've got our allergens. So there are currently under EU legislation 14 allergens that we need to control. And so we're thinking about whether those allergens are present in our raw materials, so naturally present, or whether we could potentially cause cross-contamination due to mishandling in our process. And then we have malicious and fraud. So I mentioned earlier, this is something relatively new that's been added in, a fifth hazard. It's debatable whether it should really be followed within our HACCP plan. The others are all what we call unintentional hazards. They're not meant to happen. So we don't want a piece of glass falling into our product and causing someone to cut their mouth. We don't want pathogenic bacteria to survive a cooking process. But malicious and fraud are intentional, so they are very different. I believe they should be in threat assessment plans and shouldn't really be in your HACCP, but a lot of the GFSI, Global Food Safety Initiative standards now do require that malicious and fraud is included within the HACCP study. So I do now put them in there as well. When we're doing our hazard analysis, we need to look at what we call the manifestation of our hazard. So is it present? Is it naturally present in our raw material? Have we allowed cross-contamination to occur during our process? Have we allowed the hazard to grow, which will only be for microbial? So we perhaps are allowing it to grow to large enough numbers to cause some level of harm, or have we allowed it to survive a process which is designed to destroy it, such as a heat process or a chemical process? So you always use this manifestation and this specific hazard as well. So if it was microbial, it can be any of those four. If it's chemical, it's normally going to be cross-contamination. Allergens, it could be inherently present or cross-contamination, or we could allow it to survive a cleaning process which is designed to remove the allergen property. And physical, then we could have intrinsic physical, such as bone in a chicken, but more likely it's going to be cross-contamination. So if I can say, for example, I'm worried about growth of salmonella due to ineffective temperature controls at storage, then I know when I need to control, what I need to control is my storage temperature. So the more specific we can be in our hazard analysis, the better. We use some form of risk assessment, so likelihood and severity, as I said, how likely is it that this hazard would occur? And if it did happen, what level of harm would it cause? And from that, we can then identify our significant hazards. So when you're doing that, you consider the likelihood of the hazard, the severity on the effects on the consumer safety. So who are you serving your product to? So thinking about the vulnerability and considering contamination of raw materials, etc. Different tools can be used. I use a very simple 3x3 matrix when I'm doing my risk assessment. So I've color coded it here with a traffic light system. So likelihood and severity can have a low likelihood with low, medium or high severity, a medium likelihood with low, medium or high severity, and a high likelihood with low, medium or high severity. And if we just look at it in those forms and those words, it can be difficult just to try and identify how likely or how significant a hazard is. So instead, if we give them some numbers, so low has number 1, medium and number 2, and high and number 3, and we multiply them across. 1 is our lowest score, 9 is our highest score, so 4.5 is our midway point. So 4 and above will be significant, okay? And anything that's 4 or above, then we need to control. And you should be looking at likelihood without controls. So if we didn't have controls, how likely is it that this would happen? And if it did happen, what level of harm would it cause? We then put our control in, and we will then have the opportunity to reduce our likelihood. And we'll never change our severity, but we can reduce down our likelihood. So control is an action or an activity that can be used to either prevent or eliminate a food safety hazard or reduce it to an acceptable level. So sometimes we're trying to prevent the hazard from happening. Other times we're eliminating it, for example, using a sieve, or we're reducing it to a safe level, for example, using a heat process such as cooking. So our controls are procedures, and a lot of our controls are prerequisite controls. So once we've identified our significant hazards and we're happy about controls, we can then try and identify where the critical control points in our process are. And this can be quite a tricky part of the study. By definition, it's a step where control can be applied. It's essential to prevent or eliminate a food safety hazard or reduce a food safety hazard. It's normally the last point in the process where we can control a particular hazard. Okay. By definition, everything cannot be critical. And so traditionally we are seeing companies with 2, 3, 4 critical control points. A lot of companies are now reducing down to having very few critical control points. So it's usually the last step in the process where we can control a particular hazard. So things like metal detection, cooking heat processes, X-ray machines, sieves would all be seen as being critical control processes. For these, we need to lay down parameters for them to work within, which are known as critical limits. Definition is a criteria that separates acceptability from unacceptability, safe food from potentially unsafe food. It needs to be measurable by a test or an observation and must relate back to the hazard and to the control. And you need to be able to validate your critical limits to prove that it is the point between safe and unsafe food. And that might be a legal requirement, or it might be by scientific evaluation to prove that that is going to control the particular hazard. You can use something a little bit more stringent known as target levels, and these are more stringent and allow you a bit of time to bring the process back under control before unsafe product is achieved. And so targets on occasions can be used. For example, if I was having chilled storage and my critical limit was 8 degrees, I might then set a target of 5 degrees, and that provides me with a little bit of a buffer zone. So even if I go above 5 degrees, I'm still below the critical limit, which is the 8 degrees. Okay, so I'm still in the safe zone and it buys me a little bit of time. So we need to monitor, we need to check that we're working within these critical limits. Definition is conducting a planned sequence of observations or measurements of the control parameters to assess whether we're in control or not. So monitoring needs to be able to check if we're in control or not. It needs to be robust enough to be able to determine if we're out of control. We need to look at what is the monitoring procedure. So what is the method? What are we checking and how do we check? Who is responsible for carrying out that check? They must be trained. And what is the frequency of monitoring? And so a monitoring procedure needs to be detailed out and trained out to people. Continuous online monitoring is the best form of monitoring because we're going to get continuous monitoring of our plan and get continuous data. But often we do batch monitoring. So we're doing it perhaps on an hourly basis, or we're identifying a batch of product and we're checking it per batch. Any equipment that we're using for monitoring must be calibrated, and we need to record down our monitoring results. And remember, these results then, this record is our proof that we've produced safe food, and that record may be used as a due diligence defence in future. We need to also verify that our monitoring procedures are being carried out correctly. As an unusual activity, as I would call it, on occasions you will find that the critical limits are not being achieved. Most of the time you will find they are being achieved, but on the occasions that you find they're not being achieved, we have to put in the appropriate corrective actions. So actions to be taken when results of monitoring at the CCP either indicate a trend or actual loss of control. So we need to consider what are the consequences if the critical limits are not achieved. Well, we could be producing potentially unsafe product. So we need to think about how we're going to bring that back in line. And there are different levels of corrective action. One, bring the process back into control, because until we do that, we're going to continually produce potentially unsafe product. Number two, deal with this this non-conforming product, which remember could be unsafe. You may be able to reprocess it. You may have to dispose of it. And three, root cause analysis. What went wrong? What do we need to do to prevent this happening again? So we need to be very detailed on what type of corrective action, who is responsible for each type of corrective action, and we need to verify that the corrective action has been implemented correctly. So once we've done that, then we move to our final stages of HACCP. So we've got what we call verification procedures. So these are the application methods and procedures and tests and other evaluations in addition to monitoring to determine compliance with the plan. There are two stages. Stage one is validation and stage two is verification. So validation is once we've designed it, we're checking, is it right? Is it correct? Before we implement it, we need to double check that our plan is correct. So obtaining evidence that elements of the HACCP plan are effective. Have all the significant hazards been identified? Who was involved in the process? How did they do it? Have they identified all the hazards? Is there any hazards missing? Are the controls suitable, and are they going to control the hazards we've identified? How did they identify the CCPs? Was the decision tree used, and was it used correctly? Are the critical limits the point between safe and potentially unsafe product? Will the monitoring be able to detect loss of control? For example. So once we've validated it, we then implement our plan. So we're taking our plan that we've validated, and we're going to ensure that we've got day-to-day control by putting in implementation. We take this validated plan and we put it into practice. We consider people, training, equipment, maintenance of calibration, and calibration of equipment. We think about having procedures in place that we can train out, and what records will we need to have put in place. So we take our time and we implement it. Once we've implemented our plan, then food safety should be running on a day-to-day basis, but we need to be able to prove that. And our second stage of our verification now comes into play. So there are 3 types of verification that we can use: auditing, data analysis, and sampling and testing. Auditing is a really useful tool. So you're going back after the event and making sure that we are in control and that we're doing what we said we would do. You can also get a lot of data from HACCP, and you can analyze that data. And you can use that for prerequisites as well as CCP, and that will help you, and do some trend analysis. And then final product testing or pH testing or swab results from cleaning, we can use that. And that verifies, proves that we are following our plan correctly. We need to establish documents and records, as I've already said. So records confirm that we've produced a safe product, but they can also form part of our due diligence defence. So you need to review your records and authorise them. Make sure that records are being completed accurately, that they're legible, and they are a true reflection of what's happening. And you need to be able to check those and authorise them, not just signing them off, actually verify and make sure that they are being carried out correctly. If corrective actions have been implemented, then it's important that we know that those are carried out correctly as well and implemented. We then should do a review. It should be a scheduled activity, normally once per annum. But if there are changes in addition to your scheduled activity, you will do a review. So for example, changes in raw materials and suppliers, changes in ingredients, changes in process conditions or equipment, changes in packaging, storage or distribution, changes in the use by the consumer, developments in scientific information. So new information coming to light. In the future, you then need to consider if there are any emerging pathogens of risk in your process, any emerging risks out there. Any verification evidence that you use will help you decide whether your HACCP plan is running effectively or not, or if you're selling into new markets or different markets, there may be different requirements necessary. I want to thank you for listening today. That was a very brief overview of the HACCP system. I can spend 4 days talking to people on HACCP, so I can go into an awful lot more detail. So I appreciate there was a lot of information to come through in a short period of time, but I welcome any questions that you may have. Thank you.